Now we're going to find the antiderivative of s times the quantity s plus 2 raised to the fourth power ds. This one's a little more difficult because things do not get swallowed up by the du in the same way. So let's follow our general rule and pick u to be this piece inside. So we'll let u equals s plus 2. One of the things that we haven't pursued earlier, because everything always got swallowed up in the u and du nicely, is that if u is equal to s plus 2, u minus 2 is equal to s. So if I were to subtract 2 from both sides here, I can get another equation here that I can use to change things over to u's. Let's go ahead and find du ds, which is 1, which means that du is equal to ds. I can use all of these pieces to change all of my s's here over to u's, and then I'll be able to take the antiderivative. So the way I do that is I notice that u is s plus 2, ds is the same as du, but I still have an s in the problem. So that's where the u minus 2 comes in. The s becomes u minus 2. So when I convert everything over into u's, I'm going to have a u minus 2 from the s plus 2 becomes u, and it's to the fourth power, and ds becomes du. Now this may not look like much of an improvement, but now we can distribute that u to the fourth onto both of the terms in parentheses, and that leaves us with the antiderivative of u to the fifth minus 2u to the fourth du, and each one of those I can do an antiderivative on using our power rule. So the antiderivative of u to the fifth is 1/6 u to the sixth. The antiderivative of u to the fourth is u to the fifth over 5, so 2 times that will become 2/5 u to the fifth. And now I add on my constant plus c. Our antiderivative is now complete, but to finish the problem, we need to put our u back in. So what that leaves us with is 1/6 times the quantity s plus 2 to the sixth minus 2/5 times the quantity s plus 2 to the fifth plus c.